Are you ready to do some geometry?
Ho!
All right, here in the warm-up, we got a skateboard ramp. It reaches a height of 2 feet. Let me draw a little picture here. So here's our ramp. Here's our right angle. It reaches a height of 2 feet, and it has a horizontal length of 4 feet. What is the angle the ramp makes with the ground? Draw a diagram. So here is the angle we would make with the ground. Notice from this angle's perspective, we have the opposite side and we have the adjacent side. So it looks like opposite and adjacent, we can set up a tangent ratio. The tan, I'm just going to call this angle theta, Greek letter theta. The tan of theta equals the opposite side over the adjacent side. Now remember, to get rid of this tangent, we can use the tangent inverse. If I tan inverse the left side, I'm just going to have theta equals. We have to be fair and tan inverse the other side, the fraction 2/4. So here we could just punch this in our calculator. 2 divided by 4 equals second function. Hit the tan key. You should get the angle is about 26.57 degrees. So remember, when we're looking for an angle, we use an inverse function. We're also going to be doing that today, but not with tan inverse. We'll do it with sine and cos inverses. So let's see what we got in example 1. We've got our right triangle here. What is the length of QR? So QR is the hypotenuse. We've got this angle is 70 degrees. Now when you're trying to figure out, what trig function to use, it comes down to the side that you have and the side that you want. In this triangle, we have the opposite side. We want the hypotenuse. So what trig function deals with opposites and hypotenuse? Well, the sine. The sine of the angle is equal to opposite over hypotenuse. So here we can do the sine of our 70-degree angle is equal to the opposite side, 7, over the hypotenuse. Let's just call it x. So we saw something like this when we were doing the same thing with tangent. We do want to get x by itself. So I'm going to multiply both sides by x. Now the x is over here, multiplied by the sine of 70. So to get x by itself, we will divide both sides by the sine of 70 degrees. So now if we punch this into our calculator, 7 divided by 70 sine and equals, we're going to get the length of that hypotenuse QR. It's about 7.45. Remember the side you have and the side you want. Now in this one, it says find the length of GH. Now here is GH, I'm covering over in blue, and we've got this angle is 65. So from this angle's perspective, 65, we want the adjacent side. We have the hypotenuse. So what trig function deals with adjacents and hypotenuse? Well, that would be cos. The cos of the angle equals adjacent over hypotenuse. So we know the angle, the cos of 65 degrees, is equal to the adjacent side is unknown, let's just call it x, and the hypotenuse is 5. So in this scenario, our numerator is the variable. So in my opinion, this is the easier one to solve. We're going to multiply both sides by 5. So over here, we're going to have 5 times the cosine of 65 is equal to x. So we can just punch that in our calculator, 65, hit the cos button, multiply that by 5, and you should find x to be about 2.11. Or again, we should label that GH. We are trying to find side GH. That is approximately 2.11. The side you have and the side you want. All right, example 2, it says find the perimeter of triangle ABC. Well, we've only got this side is 5 meters. We've got one angle. Angle A is 35 degrees. It says, of course, start by finding the lengths of the unknown sides in the triangle. Now, before we get started on that, let's find our other angle C up here. 90 minus 35 is 55 degrees. You know, it might make our setup easier. We can come up here and use the 55-degree angle if we want. So let's see. At first it says find side AC. AC is the hypotenuse. So if we're at the 35-degree angle and we have the adjacent side and we want the hypotenuse, we could use cos. Write it here. The cos, move it up here. The cos of 35 degrees would equal the adjacent side over hypotenuse. Let's just call it x. Now let's check the setup from the 55-degree angle. From the 55-degree angle, our opposite side is 5, and then the hypotenuse is what we want. So what trig functions are opposites and hypotenuse? That would be sine. So we could also do the sine of 55 is equal to the same thing, 5 over x. So I guess one way is not going to be easier than the other. So here, let's multiply both sides by x. Now the x is over here with the cos. And then we're going to divide through by the cos of 35. So our x value is 5 divided by the cos of 35. And we punch that in our calculator, and we get AC, side AC, is approximately 6.1 meters. So I'm going to label that up here on our triangle, 6.1. Okay, next, find side BC. Well, here is BC. We have the adjacent, we have the hypotenuse, so we have a few options. You know, again, from this 35-degree angle, BC is opposite. We have the hypotenuse. The trig functions with opposites and hypotenuse is sine. We could do the sine of 35 is equal to opposite side unknown x over hypotenuse 6.1. And let's see, we could come up here to the 55-degree angle where the unknown side BC is adjacent and we have the hypotenuse. So we could do the cos of 55 equals x over 6.1. And if we really wanted to, we could come back to the 35-degree angle and we could do the tan of 35 is equal to opposite side x over adjacent side 5. So here are 3 different setups for this. Any one of them should give us the exact same answer. BC is approximately 3.5 meters. So this side is 3.5 meters. And then our perimeter for the last calculation is we add those sides up. 3.5 plus 5 plus 6.1. Perimeter is about 14.6 meters. Now we got a little fill in the blank here. Find an angle measure using inverse sine and inverse cos. You can use the inverse sine and the inverse cos to find an angle measure when you're given the side lengths of a right triangle. So let's see here in our top box, in a right triangle with acute angle A, the sine of A would equal opposite over hypotenuse, A over C. Now, if I want to take the sine inverse of this side, I would have the sine inverse of AC. When I take the sine inverse of this sine, they're going to cancel, and that will just leave angle A. And then in our next box, in a right triangle with acute angle A, cos is equal to adjacent over hypotenuse. That'll be B over C. So if I take the cos inverse of this side, the cos and cos inverse cancel. That will just leave angle A, and that will be equal to the cos inverse of this fraction, the cos inverse of B divided by C. So here in example 3, looks like we're going to find some angles. For each triangle, use a calculator to find the measure of the given angle, round to the nearest tenth of a degree. So let's see here, our first one, we're at angle K. I'm going to mark it down here with red. And we want to find that measure of that angle. Well, let's see what sides we have. We have the opposite side and we have the hypotenuse. So the trig functions for opposites and hypotenuse is going to be sine. The sine of angle K equals opposite over hypotenuse. And then we're going to take the sine inverse of the left side, so that'll just leave angle K, is equal to the sine inverse of our fraction, 8 over 12. So we punch it in the calculator and get about 41.8 degrees. And I could write it up here in the triangle, 41.8. If we wanted to, we could now solve 41.8. We could solve for angle J by subtracting, and then we could do Pythagoras to find this missing side. Whoa. Letter B. Now we're down here at angle X. So from angle X's perspective, we have the adjacent side 6, and we have the hypotenuse 15. So what trig function deals with adjacents and hypotenuse? That's going to be cos. The cos of angle X is equal to 6 over 15. We're going to take the cos inverse of the left side, so that'll just leave angle X. And we're going to take the cos inverse of our 6 divided by 15. Punch it in the calculator. Angle X is about 23.6 degrees. Ooh, now we got one with a pretty picture. A hot air balloon is tethered with cables that run from both sides of the basket to the ground. The tethers allow riders to experience a hot air balloon ride only up to a predetermined height. When the balloon is at max height, what is the measure of angle B? So I'm going to just sort of copy the triangle down here below. Here's our relevant triangle. This is angle B. This side is 65. That's our hypotenuse. It's across from the right angle. This side here is 50 feet. So from angle B's perspective, we have the opposite side. We have the hypotenuse. So what trig functions are opposites and hypotenuse? Sine. The sine of angle B equals opposite 50 over hypotenuse 65. So we got a sine here, so let's take the sine inverse. That'll cancel, leaving only angle B. Angle B is equal to the sine inverse of 50 divided by 65. So we punch that in the calculator. 50 over 65 equals, hit the sine inverse, and we get angle B is approximately 50.3 degrees. All right. That's it for the examples. So here's the practice problems. Again, pause the video, try the problems, then start the video back up and see if you got them right. Okay, in the first one here, we want RS. So that's this side up here. That's the adjacent side to this 45-degree angle, and we have the hypotenuse. So I ask myself, what trig function deals with adjacents and hypotenuse? That's cos. The cos of 45 degrees is equal to the adjacent side, let's just call it x, and put that over 4. Now to get x by itself, it's as easy as multiplying both sides by 4. So over here, we're going to have 4 times the cos of 45 degrees is equal to x. And then we punch that in the calculator, 45 cos, multiply by 4. We get RS, the missing side, RS, is about 2.8. Okay, now this other one over here on the right looks like we got a slice of watermelon. Move this over here. We want to find PR. PR looks like the hypotenuse across from the right angle. So from the 35-degree angle's perspective, we have the opposite. We want the hypotenuse. It's about the side you have and the side you want. So opposite and hypotenuse takes us to sine. The sine of 35 degrees equals 12 over unknown x. So again, to get x alone, first we're going to multiply both sides by x, so now it's over here. Then we're going to divide by this sine of 35. So our x value is 12 divided by sine 35. We punch that in our calculator, and we get the missing hypotenuse PR is about 20.9. What's next? Use a sine or a cos ratio to find the value of each variable. Round to the nearest tenth. Then at the end, find the entire perimeter of the triangle. Okay, so let's see. I'm going to try to stick with what they give us here, the 71-degree angle. So if I'm at the 71-degree angle, I have the opposite side. And let's see here, maybe let's first find W. So from 71's perspective, W is adjacent. So what trig functions? Oh, well, it does say sine or cos. I was about to use tangent, so let's not do that. From 71, we have the opposite, and here we want the hypotenuse. So opposites and hypotenuse take us back to sine. The sine of 71 equals opposite 5 over unknown variable v. Multiply both sides by v. Divide by the sine of 71. And it's going to look like this. Punch it in the calculator. 5 divided by 71 sine. V is approximately 5.3. So I'm going to write that in there. 5.3. Now we want to use, or we want to find W. Again, from 71, W is adjacent, and now we do have the hypotenuse. So adjacent and hypotenuse are cos. We could do the cos of 71 degrees equals adjacent W over hypotenuse 5.3. And we multiply both sides by 5.3. So 71 cos times 5.3 is our W, and W then is about 1.7 units. Now for the perimeter, we're just going to add those up. The side they gave us 5 plus the 5.3 plus the 1.7 should all add up to 12. Here it says, first find y, then find z, round to the nearest tenth. Now we've got two triangles stuck together here. We got a 40 degree here, 30 here, so let's see. First we want to find y. Here's y. Now if we go from the 30-degree angle, y is opposite, and we have hypotenuse. Opposite and hypotenuse is sine. So we could set this up as the sine of 30 equals y over 150. Let's see. I guess we could not solve from the 40-degree angle's perspective because we have no sides over here yet. So we're all set to put this together. Multiply both sides by 150. 150 times the sine of 30 is equal to y. And then that turns out to be y is 75. So I'm going to come up here to my picture and write that in instead of y. That is 75, because I think we're going to need it now to find z. So now we're at the 40-degree angle. 75 is opposite, and we want the adjacent. So last section we learned about tan. Looks like we're going to need it here. The tan of 40 is equal to the opposite side, 75, divided by the adjacent side, z. We multiply by z, so now it's over here, and we're going to divide by tan 40. So z is 75 divided by the tan of 40. And z is going to be approximately 89.4. Excellent. So that was number 3. What's number 4? Oh, we got two triangles. Use a calculator, find the measure of the angle, round to the nearest tenth. So in this first one, it says find angle B. Here we are at angle B. The sides that we have are the adjacent side and the hypotenuse. Adjacent and hypotenuse means cos is going to be necessary. The cos of angle B is equal to 18 divided by 30. So we're going to cos inverse both sides, and that will leave us with angle B is equal to the cos inverse of 18 divided by 30. So we punch that in our calculator, and we get angle B is approximately 53.1 degrees. Now in the other one over here, we want angle P. Here is angle P. And from angle P's perspective, we have opposite and we have hypotenuse. So this one is going to be a sine. The sine of angle P is opposite 3.5 over hypotenuse 5. Once again, we will sine inverse. So angle P is all by itself, and it's equal to the sine inverse of our fraction, 3.5 over 5. Beep, beep goes the calculator. Angle P is about 44.4 degrees. But you already knew that because you did this problem before you watched the video, right? Right? What's next? Number 5 is next. Ooh, looks like we're going to have to draw a picture. We got a ladder leaning against a building. So here's the building. I'll do the ladder in red. The length of the ladder is 24 feet. The point where the ladder touches the side of the building is 23.1 feet above the ground. So here's where it touches the building. That is 23.1 feet above the ground. What is the measure of the angle formed by the ground and the ladder? So we want to find this angle. So from that angle's perspective, we have opposite, we have hypotenuse. Opposites and hypotenuse mean sine. The sine of angle, let's just call it angle x, is equal to opposite, 23.1, divided by hypotenuse, 24. And once again, we will sine inverse, and our angle x will be the sine inverse of 23.1 divided by 24. So we divide the fraction, we do the sine inverse button, and we get angle x, as I'm calling it, is approximately 74.3 degrees. All right, number 5 in the books. Number 6. Julio knows the measure of one of the non-right angles in a right triangle and the length of the side opposite. Explain how we can find the length of the adjacent side to the angle without using tangent. Maybe drawing a picture will help. So here's a pretty terrible right triangle. Julio knows the measure of one of the non-right angles of a right triangle. So let's just call this one down here, we'll call it question mark. And the length of the side opposite. So he knows this one. What should I do that? Let's just call it side B. Explain how we can find the length of the side adjacent without using the tangent ratio. That's the key to this. So it looks like, well, if we have opposite, we could use that to find the hypotenuse. So step 1, find hypotenuse with sine of angle, well, I should have given it a name, I guess. Find the hypotenuse with sine. We'll just say find the hypotenuse using sine. And then step 2, now that we have the hypotenuse, let's call it C. If we're at angle question mark, we want the adjacent side, and we now have the hypotenuse. So now we can use cos to find the adjacent side. Use cos to find adjacent side. There we go. Hold on. Oh, that was a 6. Number 7. Multiple parts. A guy wire is attached to a tower 80 feet above the ground. So here's my tower. We have a guy wire attached to the tower. It's attached 80 feet above the ground. The length of the wire is 130. What is the measure of the angle formed by the tower and the wire? Now be careful. It looks like they're asking us for this angle up here. Let's just call it x for now. So if we're at angle x, we have adjacent, we have hypotenuse. Adjacent and hypotenuse means cos. The cos of angle x is 80 over 130. And then we're going to take our cos inverse, and that will just leave angle x is the cos in, oh, that doesn't look like cos, is equal to cos inverse of, I'm going to reduce the fraction down to 8 over 13. There we go. And we punch that in our calculator, and we get angle x is approximately 52 degrees. 52. So I'm going to write that on my picture, 52 degrees. Part B, what is the distance between the base of the tower and the point where the wire is buried in the ground? Use a trig ratio. So we're trying to find this side. I'm just going to call it z because I already used x. So we have our 52 degree angle. From that angle's perspective, we want the opposite side, and we have the adjacent. We also have the hypotenuse. So it looks like we have some options here. We used tangent in the last couple of lessons, so let's use sine. We want the opposite side. We have the hypotenuse, so let's do the sine. The sine of 52 is equal to opposite side z over 130. Again, our alternate way to do this, we could also have done a tan of 52. Tan of 52 is equal to opposite z over adjacent 80. You know, both of these are pretty straightforward, pretty easy to punch into the calculator, and this is going to turn into about what I call it. Z is approximately 102.4 feet. 102.4. Now, it looks like I kind of spoiled part C up above here. Could you have found the distance between the base of the tower and the point where the guy wire is buried using a different trig ratio? So if I had used sine up here, I could have used tan for part C. Or if I used tan in part B, I could have used sine in part C. Usually with a lot of this trig stuff, there's usually more than one way to get the job done. And that is the last problem in the huddle. That's the end of the video. I'll see you in class.